Assalamualaikum and good day. My name is Muhammad AZRI bin Abbas. My number military is 2012622729. Okay, I'm from class RY31 Power Industry. Okay, today I would like to present about introduction about Coulomb's law. Okay, Coulomb's law is a theoretical experiment that calculate the force applied by two electricity charged particles that are stationary. Okay, the electric force that exists between two charged objects that are at rest is also known as electrostatic force or Coulomb force. Okay, I thought the rules exist before to 1785. Okay, the name derived Coulomb's law from the fact by scientist Charles Augustin de Coulomb that was published in 1785. Okay, Coulomb's law was crucial to the development of electromagnetic theory, maybe even to its creation, because it allowed for genuine argument over the quantity of electric charge. The amount of electrostatic force of appeal between two-point charge was indeed equivalent to their magnitude, and also inversely relative to the square of the region between them as shown in the law. Okay, for my formula as shown in law, magnitude F equal to K magnitude Q1 multiple Q2 per R square. Okay, for K represent Coulombs as constant. K equal to 8.988109 and M 2C2. Okay, the distance between the charge is denoted by R, and the sign magnitude of the charge are denoted by Q1 and Q2. Okay, the force applied in between two charge in a straight line. Okay, the electrostatic pressure force among two charge which have the same sign is repulsive. Okay, the force is drawn which the charge have opposite signs. Okay, that's all from me. Thank you.
Very good day. My name is Muhammad FIRDAUS bin JOHARI, street number 2012-9245 from RY31 in group 5, which is Coulomb's law. I will continue with the review of concept. Okay, Coulomb first law. What is Coulomb in first law? Coulomb first law states that two charges particles of same charges, positive or negative, will repel each other, and two charged particles of opposite charges, one positive and one negative, will attract each other, like the figure below. Okay, what is Coulomb's second law? Coulomb's second law states that the force of attraction or repulsion between two electrically charged objects is directly proportional to the magnitude of their charge and inversely proportional to the square of the distance between them. We can find the force by using the formula, which is F equals to K, the Coulomb constant, times with the magnitude of charge 1 and charge 2 divided by the distance squared. Okay, the Coulomb constant. The Coulomb constant is the electrical force constant or the electrostatic constant, denoted which by K or K is a proportionality constant in electrostatic equation. In SI units, it is equal to 8.988 times 10 to the power of 9, and the unit is N times meter squared times the Coulomb the power of negative 2. Our Coulomb constant is equal as 1 over 4 pi times the permittivity in vacuum and the relative permittivity in medium with respect to free space. When force between two electric charges placed in vacuum, our permittivity in medium is equal to 1. So our formula will be as F equal to magnitude of Q1, Q2 divided by 4 pi times with our permittivity of in vacuum times with with the distance square. When forces between two electric charges placed is medium, our formula will be F equal to magnitude of Q1 times Q2 divided by 4 pi permittivity in vacuum times with permittivity in medium and times with the distance square between the two charges. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad LUTFI HADI bin Cik Muhammad Zan, Matric 2012-92735. I want to talk about the background of studies, the Coulomb's law. Coulomb's law deals with the force a point charge exerts on another point charge. It can be used to develop expressions relating the electric field intensity E and electric flux density D. In 1785, Charles Augustin de Coulomb formulated law about the interaction of force between two charged particles. He demonstrated that two like charges repel one another, whereas two charges of opposite polarity attract. Second, the force acts along the line joining the charges. And third is its strength is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of distance between them. Coulomb's law gives the force between 2 point charges, which is the force is along the line connecting the charges and is attractive if the charges are opposite and repulsive if the charges are like. And this is how the force on the two charges are action and reaction forces. That's all for me.
Assalamualaikum, my name is Muhammad IMRAN and we explain about design procedure of Coulomb law. An example for Coulomb law is mixing substance in water. The polarity of substance is critical to Coulomb law to occur. A polar compound such as sodium chloride, often known as table salt, attract and dissolve readily in water because of its polar property in nature. A non-polar material like oil, on the other hand, is incapable of forming chemical bonds with water. There is an electrical intersection between the solute and the solvent in this situation. Xerox machine. A Xerox machine is made up of many components such as hydrogen lamp, a photosynthesis sensitive drum and ink drum, and a system for providing blank paper. The blank paper is then scanned with the aid of laser beam, and due to the drum photosensitive nature, the section exposed to the light begin to behave like a conductor, while the area are not exposed to light stay negatively charged. Therefore, the Coulomb law is applicable in this machine. Next, the application of Coulomb law is charge rod. When a glass rod is rubber with specific type of clothes such as wool and synthetic clothes, it becomes charged, and charge rod is capable of exerting a force of attraction or repulsion on the item that it comes into contact with, such as the light item like feather or balloon. That's why the Coulomb law can occur in this situation. Thank you.
Good evening. My name is Muhammad IZZAT bin NURUDDIN. My numeric is 2012925569. So today I will discuss about Coulomb's law. Before that, I am from Group 5. So Coulomb's law predicts that the intensity of electrostatics attraction or repulsive force between two opposing forces. Next, Coulomb's law states that the magnitude of the force may be repelling or attract to each other, indicating the direction of the force between the two charges. But the magnitude of the electric attraction remain unknown. According to Coulomb's law, as the particle move away, the electromagnetic force decrease as a function of the magnitude of the charges. The magnitude of electromagnetic interaction is equal to the product of the charge magnitude. Coulomb's law has many limitations, including the fact that it only can be computed under certain circumstances and cannot be utilized freely, as other universal equation may. The rule is only applicable if the charge is constant and at rest, in which case that formula may be used. When engaging with the charges that have normal and smoother form, the approach is simple to utilize. But when dealing with the charges that have unusual shape, the process becomes more difficult. So next, I will talk about the conclusion of Coulomb's law. Coulomb's law may be used to compute the electromagnetic attraction or repellence force between two charges. The relative primitive of a medium if the direct constant value of a certain medium is known. The magnetic force due to the charged particle in the medium may be calculated. We cannot find an electric field due to continuous charge distribution or an applied electric due to the line charge due to the limit of the rule. Coulomb's law has provided numerous benefits to our civilization and is critical to understand more about its use in order to develop our technology. So that's all for my part. Thank you.
Okay, hello, and very good day. Okay, my name is Muhammad AZRI bin Abbas. My number is 2012922729. Okay, today I would like to present about my reference. Okay, my first reference is lesson 3 electric force from static electricity by TP classroom. Okay, my second reference is Coulomb's law by editorial. Okay, my third reference is Coulomb's law too by Lumen. Okay, by four my reference is physics and radio electronic. That's created in 2013 until 2015. Okay, then the author is radio electronic. Okay, for five reference is Coulomb's law too, created by Encyclopedia. Okay, 6 Coulomb's law too, but the author created by IJS material. Okay, 7 definition, equation and derivation. That's created by that's Coulomb's law. Coulomb's law, definition, equation and derivation. Okay, 8 Coulomb's law example in daily life. In daily life by Clyde, right? By Clyde, C-L-E-I-D, Clyde. Okay. Okay, for 9, Coulomb's Law 2 by Khan Academy. Okay, last one is Coulomb's Law 2 by Eka Phil. Okay, that's all from me. Thank you.